Alright, so here I will be duplicating this file, and I will put the name as the cooling tower for CFD. Okay, double click here and I will open this file so that I can create the domain around this cooling tower geometry for the CFD analysis. Okay, choose this plane, which is the YZ plane, and on this plane, first of all, right click in the screen and click on the left. So we are just going to make the domain for this geometry basically, and I will choose this line first, and the domain size, because the bottom diameter of this geometry is equal to 39.3, so this will be the, let's say it's a 40, so 40 plus 40 is a 80. So upstream will be the 800, downstream would be the 1600. Okay, so first of all decide about this upstream. This upstream would be equal to the so this line would be equal to the 800, 10 times of this bottom diameter, and the downstream side is going to be equal to the 1600. Okay, next thing is that we should be having the dimension up to this top, and after making this dimension, the next thing is that the top of this after the above this geometry, I guess that the 600 would be enough. So instead of the 800, I am going to make this one as the 600. Okay, now make the lines here in this way, and this will also, the Spaceclaim will also give you the option that this line, if you click this point here, this will give you the line, this line is in a straight line, and simply delete this line from the model here like this. Okay, delete this line also, and now you create two lines from these two locations on the top and the bottom, so that we can have the only single line. Instead of the multiple lines, we can have the single lines. And now click on the add and sketch editing. So now we are with this surface. So I'm just going to make the domain size on the both sides, and that would be equal to the 800 on the both sides. So I will use this command, that is on the pull both sides, and the no merge. Total will be equal to the 1600. Apply. And now I just want to see that how this will look like with this domain. So make it transparent. And I guess that on the both sides this is okay. On the top side this is also okay, and the same is the case with this inlet part. Okay, now just hide this plane, and from the combine command I will choose this geometry as my main geometry, and the inner geometry would be my tool geometry, which is used here. And so again I will choose this geometry as my main geometry, and then hide this main geometry and choose this as the tool geometry for this model. Okay, let me do it again. Okay, so I'm going to use the pull command, this combine command. So this geometry first, and then this geometry, and we can delete these extra parts from here. So just hide this geometry. And read from screen. So the extra part, which is a part of this outer domain, is now deleted. And again we delete this geometry and just leave this with this domain file. This domain, which just contains this box minus this cooling tower. So now we have only geometry of cooling tower is the its outermost surfaces. Okay, now we can save the project file, and the name of this project file would be equal to the same name as we did for the our main case. This is the our one-way FSI cooling tower. Okay, now we will be working on the same model here, and the remaining things we will work on is their name selections. So I will be putting the name as the inlet for this boundary. So far we have defined the boundary condition for this inlet section, side 1, and top, side 2, outlet, bottom, and the cooling tower inlet part, inlet surface, in fact, cooling tower outer surface, and cooling tower the top side, cooling tower bottom side. The remaining ones are these parts here, and I will simply choose these all parts here. Okay, these parts, and then again these parts. So these are all the supports for the cooling tower, and I will be putting name as the cooling tower supports. Okay, now again I will be saving the project file and click on the save project file. Okay, so far we are done with the geometry part for this case here. Okay, in the next part we are going to make the tetra and prism meshing for this geometry that is for the fluent